In this video, we are going to be going through our notes package to fill in the blanks so that you're able to complete your Scientific Method Workbook. So, this is a sheet on the scientific method, and if you remember, the scientific method is the proper way that scientists ask questions and do their experiments properly in order to know that the results that they get are the most valid or the most true possible. So the scientific method has 6 steps in it. Let's start off with number 1, identifying the problem. So a scientist, just like yourself, has gone out in the world and noticed something that they didn't understand. Now we're going to be following with an example throughout this notes package. And the example that we're going to use is you're eating your breakfast and you've just buttered your toast. And you drop it on the floor, and somehow, you've done this a couple times, and it always manages to land with the buttered side on the floor, ruining your breakfast. So our problem is that buttered toast lands with buttered side down more often than not. But problems are always written in the form of a question. Hint, hint. A question, so you have to actually make it so that there's a question mark at the end. So our problem for this experiment will be, does buttered toast land on the buttered side more often than not when dropped from the counter? Now let's go with this. You can't just go out and, in science, go ahead and go right to your experiment. You have to do a little bit of research first, so get your background information. You have to learn what has been done before about this experiment. You can get this information from resources like books, scientific journals, magazines, interviews, anything that you find on the internet or anywhere else that is done properly. The important part here is to never plagiarize. So plagiarism is when you don't give credit to someone else's work. So if someone's gone out and done a whole bunch of research on something, you want to give them the credit. After you've done that, you want to form a hypothesis. Now, a hypothesis is an educated guess. For us, our hypothesis should be bread that is dropped from the counter will land on the buttered side more than 50% of the time. A hypothesis is always based on your research and experience. Sometimes your experiments will prove your hypothesis to be incorrect, and that's okay. Sometimes our experiments leave us with more questions than we had before. But remember, our hypothesis is our educated guess as to what will happen in our experiment. That brings us to step 4, procedure and experiment. This is where we are actually going to design and complete our experiment. Your experiment is testing your hypothesis. You have to create a number of steps that are numbered and put into list form. So you're going to completely design it before you ever even start actually doing your experiment. For us, we'll start with our material list. So, a numbered list of everything you need to use to conduct your experiments. For our toast experiment, it could be toast, butter, bread, a knife to spread the butter, and anything else that we would need. So for our experiment, we're going to look at a couple of different things that we have to think about when creating it. Number 1, observations. Record what happens in the experiment, what you see, and keep a logbook or journal of everything you do and see, including errors. So it's good science to write everything down as you go, because you might not notice things, and too much information is better than not enough information. Or second, inferring. What can you imply or infer from what you observed? So you're actually looking at what happened and seeing how it relates to your hypothesis. Now you're going to do more of that later, and you don't want to do your analysis during your experiment, but you can already start to see trends. Number 3, independent variable. The independent variable is the part of the experiment that you change to see how it affects the dependent variable. So it's the thing that you're changing in your experiment to see if you get your results. In this experiment, it would be the buttered toast. The butter on the toast is what has changed to the toast to see if it lands on one side more often than the other side. The dependent variable, the part of the experiment that changes in response to the changes you made in the independent variable. So for us, that would be the number of times that the toast falls with the butter side down. Number 5, control. So control is doing the experiment without the butter on it to see if bread naturally falls on one side more often than the other. So it's used to show that your independent variable or your experiment is actually the result of the thing that you are changing in it. So it's used for comparing. Number 6, sample size. So good experiments have large sample sizes to increase the accuracy of results. So you might, and for ours, we're going to drop our toast 10 times in this video, but in order for it to be the most accurate possible, you might want to drop your bread 100 times or 1,000 times in order to really be able to say for sure that it does land more often on the buttered side than not. Repetition. Repeating experiments several times to ensure against experimental error and increase the size of results. So just like increasing the sample size, you can do your experiment over to see if your results are accurate. So let's actually complete our experiment now. I'm going to speed it up for you, and you'll be able to see me drop the bread as carefully as I can, just like this, from counter height when it's toasted, and you're going to observe whether it lands on the buttered side or the non-buttered side. Make a guess now. Now that we have the results of the experiment, that being that the bread landed on the buttered side down 7 out of the 10 times, this is where we're going to actually look at that in the results/data, which is Sept 5. This is the information that you gather from your experiment. There are 2 different types of information you gather. There is quantitative data and qualitative data. The first one, quantitative data, you can think of quantity. We measure quantities in numbers. So quantitative data is recorded on charts, tables, and graphs and is the most necessary. So scientists like quantitative data the best. This time we measured the number of times that it landed on the buttered side down. Qualitative data, qualitative is similar to quality, so it's more of a description type of data. It is that it includes illustrations and photographs and other sources of information that you have observed with your words or other descriptive factors. So now that you have your data, step 6, your conclusion. This is a summary of your results. And the way that you present or talk about your conclusions is that you state whether or not your hypothesis was correct. Was your educated guess at the beginning correct, or do you need or have more questions now. What practical application does your project have, and or describe a possible extension? Why did we measure this toast? Well, now that I know that toast usually lands on the buttered side down, I'm going to be extra careful once I butter my bread that I don't drop it, or any other conclusions that you think you can draw from that. You can also then identify any and all possible errors. My experiment was not perfect. Maybe I held the bread wrong when I dropped it and it kind of made it so that it would land on the buttered side. Maybe I need to do it more than 10 times in order to be confident that my results are true and the best representation of the experiment. So any and all problems that you might have had or think you can see, this is a point where you can say them. And it's not a bad thing. It's not that, ooh, I'm going to be embarrassed that I made a couple of errors. No, in science you're always learning. So you're always looking for ways that you can improve on your experiments. And that's the last point. What could you do differently to improve your project? And that's the scientific method. That's the way that scientists and researchers answer questions in order to try and understand the world around us a little bit better. Now that you have done your notes, you can take out your Scientific Method Workbook and try and work through the problems that are in there.